Hello. The question is the resistance of a meter bridge AB is given in figure is 4 ohms with the cell of EMF E is 0.5. The rheostat RH is given as 2 ohms. The null point is obtained at the same point J for if rheostat is 6 ohms. The E2 will be. So what we have given 6 volts this, 2 volt for rheostat and 4 volt for this. So current I can found it. What is I? E divided by R equivalent. Fine, so I can find it 6 divided by this is 4 or 2. That is 1 ampere. Fine. Now we have to find the potential gradient. So we can find VAB. That is what? I into R of AB. I is given as 1. This is R of AB is 4 ohm. So this is 4. Now I am going to find the potential gradient. Potential gradient will be 4. Let the length will be given by L. Now E1. Suppose E1 have balancing point of L. So what can I write? E1 is what? Potential gradient into small l. And potential gradient it was 4 by capital L into small l. This is the value of E1. Fine. And E1 is given as what? 0.5. This is equation 1. Now in the second condition it says that if rheostatic resistance is 6 ohms, if rheostatic resistance is 6 ohm and balancing point is same, then we have to find E2. Fine. So new current, that is going to be 6 divided by, again this becomes 6, rheostatic this is becoming 6 and 6, that is 6 by 12, 1 by 2. No, snot will be 6 by 6 because I can write it 4 by 6. That will be correct. Fine. This 6 is what? This is value of E. This is value of rheostatic and the potentiometer wire. Now the potential gradient will be what? For potential gradient again I will find VAB. V will be what? 6 by 10 into 4. Fine. Now potential gradient will be what? VAB divided by L, that is 24 divided by 10. Fine. If it's 24 divided by 10, so E2 balancing point is same, that will be potential gradient into L. Potential gradient is 2.4 into L, that is E2. Now this is equation 1. This is equation 2. To find E2, I am going to divide E2 by E1. E2 is what? 2.4 into L. Fine. For this one, I can write it what? 4 into L. This is L. Fine. So it's 24 by L. L getting cancelled out. This is cancelled out. So I will be getting 24 by L divided by 4 by L. L by 6. Fine. So E2 divided by E1 is equal to what? 24 by 10 into E1. I can take E1 here and V1 we know already, that is 0.5. If I solve it, it becomes what? 21.2.
Hi everyone, so we are given with a question which says a potentiometer wire AB having length capital L and resistance of 2Lr is joined to a cell D having EMF E by 2 and internal resistance is given as 3R is connected. The length AJ at which galvanometer in the figure shows no deflection. So this is the basic case of potentiometer, so in which we are interested in finding the length, that is the null point is obtained at point J, so we are interested in finding this length AJ. Let's suppose it has to be X, or we can say it has to be the balancing length. So as per the given question, this battery source is having a resistance, having internal resistance value small r, so we can say uh, at this point A we have some potential, and if we consider this point B to be having a potential of 0 uh, towards the negative terminal of the battery, so at this point we can clearly see there will be some potential drop due to this internal resistance. So we are first interested in finding the potential drop, or we can say the potential at point A. Once we get the potential at point A, we can be able to calculate the value X by using the potentiometer principle. Alright, so to calculate this value, first we have to calculate the total resistance, because the current is flowing in this section. Alright, in the upper section, or we can say in the primary circuit, the current is flowing, and no current flows in this section, as we have already studied about the potentiometer. So first we have to calculate the value of current. So current can be calculated using Ohm's law. So it can be given as E by total resistance, that is small r of this internal resistance, and total resistance of AB, that is given as 12R. So it will become total of 13R. So this much value of current is flowing in this section. So now we can be able to calculate the potential at A, because we know the resistance in the section AB is given as 12R. So we can write potential at point A, or we can simply say it has to be potential across wire AB, can be written as, against by Ohm's law we can write, so E by 13R is the current and resistance is given as 12R. So from here we can say the value of potential difference across AB or potentiometer wire is coming out to be 12 E by R. We are taking instead of epsilon we are taking it as E, so that it doesn't make any difference. So let's say we are taking it as to be epsilon only. To avoid any confusion, we are taking it as per the given question. So this is what the potential difference across wire, potentiometer wire, we have calculated. So here it is 13. So this much potential at point A we have calculated, or this much potential drop will be there across this wire. So to calculate the value of X, we have to use the first application of potentiometer, that is in which we are interested in finding the unknown EMF of the cell. So as we know there is no current flowing in this section, that is due to the potential at A and J is same as that this 2 point. That's the reason we can say there is no current flowing in this section, or galvanometer is showing null deflection. So we can write whatever potential is there across in this section, that is A by 2. So now we can say E by 2, that is epsilon by 2, will be equals to this is nothing but this is potential gradient, that is we can write it as to be the potential drop across this section is VAB by L into in this section we can say across AJ it will be V by A into L into X, that is it is nothing but this section is known as potential gradient, or it is sometimes denoted with letter K. Alright, so this is how we can say the potential across both of these are same, so we are just equating it. So potential across AJ will be V by L into X. So from here we have calculated already V by VAB, so it is 12 epsilon by 13L into X epsilon by 2. From here epsilon get cancelled out, so we are left with 13 by 24 into L. So this is what the value of X we are getting, or balancing length we are getting. So this matches with option C. I hope you have understood the concept well, and thank you for watching.